I'm Celia Bella with the Maharishi Vastu office for North America. In today's webinar, Jon Lipman, AIA, our Chief Vastu Architect for North America, will discuss the ways in which solar energy complements Maharishi Vastu buildings. Jon will be joined by Brian Robbins, who is a certified solar installer and a master electrician, who has installed over 1,000 photovoltaic energy systems. Brian works for Ideal Energy, Inc., which is the Fairfield, Iowa-based solar installation company founded by two MIU alumni. Brian will not be able to be live with us right now, and so we have pre-recorded his section of the webinar. Now, Jon, we turn it over to you.
Thank you, Celia. Photovoltaic electric generation, solar energy has occupied a special role in Maharishi Vastu architecture and planning. And we're going to talk about its widely understood benefits, which we also endorse. But before we do, we want to bring out the understanding in Vastu that the sun has certain special values, which is that the sun is the source of organizing intelligence in our solar system. And it's our solar system's connection to wholeness. So using solar energy may be understood to reinforce our connection with the sun and therefore with nature's organizing intelligence with wholeness. Maharishi Mahesh Yogi, the founder of the system of Maharishi Vastu architecture, personally was extremely keen to stay up on solar technologies, and he sent representatives several times to large solar expos to find out what the latest developments were and to give him reports. Most notably, Maharishi's worldwide organization founded and operated a solar panel production in India that operated for quite a few years. And our worldwide organization has installed numerous solar panels and solar ovens for free in the third world. What's especially notable is what our flagship university, Maharishi International University, has done to date. First, at the Sustainable Living Center, which I had the great honor of designing, which is America's and perhaps the world's first four-year sustainable living program. In its building, we designed a building which is 100% energy efficient, and almost 100% of that is powered by solar. Second, those of you who live in the Fairfield, Iowa area or have been in the last 8 years have noticed that in front of the men's Golden Dome of Knowledge is a huge photovoltaic array, which when installed began to provide a significant percentage of the university's energy. Subsequently, the university set as policy that its goal is to get to 100% off-grid energy generation, 100% solar generation. And about 2 years ago, Maharishi International University installed something called the Mega Ray Solar Power Plant, which is one of the most advanced solar arrays in the world. It's the first system in the Midwestern United States to combine two leading edge technologies on a large scale, active solar tracking and vanadium flow batteries. And there are different kinds of energy that we can get from the sun. One is using the energy of the sun directly to warm the air in a house. This is either called passive solar, or if it's done in different ways, it's called solar air. And the second way is called solar thermal, where the radiant heat of the sun is used directly to heat water so that we have hot water heated by the sun. I had hoped to talk about these two systems of solar energy in this webinar, but as it turns out, we're filling up the webinar just talking about the third and most widely thought of system of using the sun's energy, which is what we're going to talk about right now. And it's called photovoltaic electric energy, or PV. And as Celia mentioned, our expert on this, Brian Robbins, is caught up right now. It's daytime in the United States, and he's working on solar installations. And while he joined us in our last version of the webinar on Thursday evening, he wasn't able to break away to join us right now. So if you'll bear with me for a minute, I'm going to start a video from last Thursday's talk in which Brian and I do a Q&A, and he teaches us about PV, about photovoltaic solar energy. So I start by asking him the question, what are the benefits of PV?
Well, you know, I guess it just depends the perspective that you'd like to take. There's a lot of different benefits coming from a lot of different perspectives. So for me, I just really enjoy participating in something that's kind of hooking you directly into current solar energy hitting the earth. That's kind of fun. There's a lot of financial benefits, you know, as far as tax incentives. There are, you know, there's a financial benefit to just sort of like zeroing out your power bill and gaining a credit, depending on what programs, tariffs, we call them, you know, the structure of how you financially interact with your utility. So that can be very beneficial. If you go a certain route with solar, you can add a lot of resilience, a lot of backup power to supplement or in some cases replace a generator system. So I'd say there's financial benefits, environmental benefits, security benefits, and then you could say maybe there are spiritual benefits as well, depending on how you want to see it.
And I'd like to really emphasize the environmental benefits and unpack them just for a minute. Buildings are one of the major users of electricity in the United States and around much of the world. And so therefore they're a major contributor to the carbon footprint of the world, to the degree to which we are imparting carbon into the atmosphere, which is causing swings in temperature, which are, of course, potentially disastrous for life on Earth. And anything that we can do, therefore, to reduce the need for coal-fired power plants is potentially a real contribution that we can make to the longevity of life on Earth. And coal-fired power plants are built when demand by customers increases enough. And so if enough customers generate their own electricity, then that means that 1 or 2 or 3 or 4 coal-fired power plants will not get built. And
Indeed.
that will make a huge contribution to the environment long term. Brian, there are 2 main kinds of PV. One is called grid-tied and one is off-grid. Which is the most common one, and can you explain to us what the difference between those?
Of course, yeah. By far the most common, and when I say by far, I'd say up to 98% of what I've worked on, what I've installed, is grid-tied. And we call this a utility interactive system. It actually receives it's basically a solar power system that is sourced in the grid itself, meaning that the grid actually has to be powered up. And while you're connected to the grid, the inverter kind of like wakes up. You harvest solar energy. Basically, you feed your current house loads, you kind of top it off. And then in real time, if you produce more than what your house needs, you kind of overflow the cup, so to speak, and it flows back into the grid, and it will spin your meter backwards. That's how it works. And one of the biggest sort of surprises that people have to get used to with this, a utility interactive system, is that when the grid goes down, so do you. So we always have to kind of be clear with that, in the sales process. I do not know where your helmet is. Sorry.
I'm going to mention that Brian is kind enough to do this with us from home, where he is providing childcare for his kids and maybe some of the kids in the neighborhood. So we may get kid bombed during this and just enjoy it.
Oh, I've been kid bombed in a major way. Yeah. So that's utility interactive, and that's by far the most common. It's also the most financially simple system, meaning that your solar power system is going to produce a fairly regular amount of energy over time. So you can kind of calculate that. You can plan on the snow loads, the cloud, things like that. You can just kind of plan on how much you're going to produce. And if your utility, which ours does, and in fact the major utilities in Iowa do, participates this way with you, they'll do what's called net metering. So all of your excess electricity that you feed back into the meter gets credited to you. And then when you use it, like at night, in cloudy times and winter times, they'll give it back to you, like with your own stored credit. So it's kind of like a really efficient battery. So that's grid tied. The other extreme would be off grid. Like John, you're just so much more qualified to speak about that. I've built quite a few systems, but John, you're off grid, which is so cool.
And that means that I'm not connected to the electric utility at all.
No.
And what it needs, therefore, is for me to have some way of storing the electricity that the photovoltaic electric panels generate when exposed to the sun, to be able to use that electricity when the sun is not there, that is at night. And so that requires batteries.
With your usual, like typical grid-tied system, you've got your photovoltaic array up on the roof, and that uses a solid state, a silicon chemistry that actually produce, like when photons hit the electrons in the silicon atoms, it knocks them free, it knocks them loose. So they kind of follow those atoms down that right. Yeah, there you go. But that's DC electricity. It has got most of our common North American appliances, power and lighting usage. We use AC electricity. So we have an inverter which takes the DC electricity coming from the roof, from your DC array, and that inverts it through some switching, and it inverts it to mimic that sine wave that your house can then use. And that just goes from the inverter back into your panel, and the panel is connected to all of your appliances, and then back into the, back through the meter to the grid. So that's just really, really easy. Now, in an off-grid system like John's, you will actually have the photovoltaic array producing DC off your roof or pole or whatever, ground mount. That will feed back through a charge controller. And what this does is it takes the voltage and current from your array and it converts it. It's a DC to DC converter. So the charge controller kind of guards your batteries, protects them, and conditions the power from the roof. And then there's the batteries, and they're just basically a chemical storage depot for their stored electrochemical energy. There's a lot of neat stuff coming out right now, a lot of lithium ion. I've even installed saltwater batteries, a lot of cool things happening there. Now the inverter, it will actually take from your batteries, DC, and invert that to AC to give back to your loads. And that basically that just depends on your loads that might be calling. If you put toast in the toaster and push on, it basically creates a load, a draw, and your inverter will sense that and pull electricity from the battery, changing it from DC to AC, and then that will power your loads. So and then I just wanted to add, there are multimodal and bimodal and multimodal systems where we are connected to the grid, and we have batteries, sometimes even a generator, and so you really have the sky's the limit with versatility on these systems.
Well, that's a good pun because it's all coming from the sky.
I wasn't going to mention it, but yeah, it's true. I love the puns.
And Brian, we know that there are two major places where your panels may get mounted. And here we see two photographs of panels that were mounted, I'm sure, by you, by Ideal Energy. In fact, I know that.
We mounted those, that's right.
And and they're both, one is on top and one is in front of Maharishi Vastu residences. And why don't you use these photographs to describe to us the two different main ways that panels are mounted?
Absolutely. So on the top, that system is your traditional, so to speak, like rack and rail system. So your trusses are going, in this case, your trusses are going, from peak down to eave. And we're actually screwing with lag screws feet into those trusses. And that's just the support structure into your rafters and truss work. And then we just mount the panels on the roof. So the DC goes down through the attic in this case, and then it pipes down to the inverters. And then down on the bottom there is just a pole mount. And so that one's, those are kind of cool. You get to get it off your house. There's a certain different set of regulations. It's a little more lax. The only thing with the ground mount, they can be more expensive because there's a lot more, those poles are pile driven, like, 10 feet sometimes into the ground. And your wiring gets a little more expensive sometimes because sometimes the pole mounts tend to be farther away. So we have voltage drop issues. Basically, we don't like you to lose any of your electricity to the wires themselves. So we have to kind of pile drive the posts and then beef up the wires for ground mounts. But people like those a lot too because they're just, you don't have that roof thing going on. So.
And I'll mention a couple of other things, pros and cons about the two systems. One is that for your panels to generate electricity, they have to have an unencumbered path to the sun. And if there's another house to the south of you, if you're in the northern hemisphere, that is very close to you, or a tree, then it could be that nowhere in your yard could you mount panels just a few feet off the ground where they would stay free of shadow year round. But your roof, of course, is quite a bit higher than the ground. So that's an advantage. A disadvantage is that when the panels are covered by snow, if you're in a climate that gets enough snow piled during the winter, when they're covered with snow, they don't generate any electricity. And if they're on the roof, it's not very practical to clean them off. But if they're on a pole just a few feet above the ground, they can easily be cleaned off. Well, Brian, why don't you, let's see, I think I'm going to go off of the slides now. I think that's my last slide for right now. And then I've got a next question for you. What is the typical cost of a grid-tied system, and then the added cost of going off the grid? And can you tell us a little bit about how in the United States federal tax incentives lower that cost, and in the state of Iowa, and this of course varies from state to state, how that cost is reduced further?
Sorry, I was muted, sorry. So right now we're at a point where we're at about, these really are quite custom projects, right? But we're at a kind of a wide-ranging average on residential projects of about $2.25 a watt if it's around a 20 kW system. So if you shrink the system down, as you shrink, it gets a little more expensive. So if you get down to, like, say, the 5 kilowatt range, you might be getting up towards $2.80 a watt. Some kind of weird situations you could push 3, but it's rare. Now, if you go, higher than 20 kW, the costs just start to come down because efficiency of operations. And when you get to commercial, you get down $1.98, $1.80, you start sinking quite a bit. Say for a small home, looking at like around 15,000 all in up front. For a medium home, you might be looking at like between 45 and 50, but your costs are actually, even though you're going up gross, they're kind of coming down a little bit per watt, which is kind of cool. So now the way that you're getting helped by the state right now and the federal, there's something called the ITC, which is the investment tax credit. That has actually gone down. I actually asked Aurelian today. He's our kind of tax man. That's actually gone down from 30 to 26% now. It's in like a sunset period.
Mm.
That's scheduled to go to 22% next year. And then that will drop to 10% in 2022, and that should flatline there. So essentially,
What that means is that the cost is reduced by that percentage.
but it's really reduced by that amount. So if you have, like, say, for example, a $16,000 array, okay? You'll be getting $3,500 off of that in tax credits, right? But then from the state, you're getting half of that back. So you're getting around, $1,750. So you're getting like $5,300 off of that 15 grand in tax credits, like right away. If it's a commercial site, you can also do all of your depreciation like in the first year. So that's a massive credit coming back also that you can use you can use that liquidity for other capital expenditures, which is really nice. So, but that's like, so that's in it's the federal and the state, and that's kind of in a sunset period, but there's still plenty there. So.
And then in the case of my own house, our system, which is perhaps more than we need, would have been about $17,000 if it was grid tied, and was $23,000 off grid with the addition of the batteries, et cetera. And then of course, we got those federal and state tax credits off of it, so we paid substantially less than that. And then in my case, I pay no electric bills at all ever, and if you're grid tied, you pay much reduced bills, and perhaps possibly an average over the year you pay none either. Let's go on to another question. Is either kind of installation do it yourself? If not, how are design and installation usually handled?
Now to have a grid tied system, again, that's 99% of the system, 98, 99%. You really can't do it yourself in a sense because you need an electrical permit, and you basically need a master electrician in this state to pull one of those, and you need to have the utility and the state inspectors involved. So you really, you can work on your system, but a kind of a straightforward grid tied system is not really a do-it-yourself project. The off-grid systems, as Jon can attest, it's probably best to have some professional consultation to actually get it in. But once it's in, you're really kind of becoming a do-it-yourself utility, mini utility. You are sailing your ship, sir, over there. So, is that kind of a reasonable answer? You can try.
I think that's a great answer, and I'll add one more little tidbit. For anyone who's in the upper Midwest of the United States who wants to contemplate what might be involved in doing it yourself, there's a fantastic resource which is actually, well, I was going to say it's coming up, except the conference is, of course, not being held this year. There's an organization called MREA, Midwest Renewable Energy Association, I think, which holds a fantastic convention in Wisconsin every June, where they have workshops, and you can learn the rudiments of doing installations at these, but they have lots of training online as well, and probably it's accessible online from anywhere. So MREA is a source, but I don't want to dispute anything that Brian said. The thought of doing it yourself is only for people who have a strong technical background, plenty of time, and a willingness to learn a lot of information. It's not for most people. And assuming that you hire a great firm like your firm, then tell me about how long does an installation take?
Oh, I mean, the pictures that you showed of North Campus Village,
yes,
we can knock that out in a day. The ground mount, maybe 2.5 days, because you got to get the pile driver and the trencher in and everything like that. The pile driver, the trencher, the racks, the rails. Now you can go up to 3.5 days sometimes if there's a lot of electrical rework to do. But I'd say if you it's within a week, you know, most projects. Now, for an off-the-grid system, you know, that's going to take a little longer. That's
Although
going to take.
I will say that in the case of our system, by 9 o'clock or maybe 10 o'clock the first night, it was up and running.
Cool.
So
That's cool.
it is possible for both systems in some cases to be done in one day. So
Awesome.
but of course, you're just watching, so it doesn't really matter how long. But I wanted to give the public the understanding that this happens real fast. So I'm sure that if we don't bring it up, people are going to ask about new developments by Tesla. Okay, here we see a modern building, a house, and the roof is what's called a Tesla solar roof. It is those tiles are actually producing solar electricity. Brian, do you have anything to say about the Tesla solar roof tile system?
You know, truthfully, John, only that they're really hard to get.
I will add that these systems, according to the web, cost about $23 a square foot. So they're very expensive. They're economical if you are planning to put up a ceramic tile roof, a very high-end roof, because this will replace the roof. I will also say, echoing what Brian said, that they are not available in most of the country. And in fact, to date, according to information just published yesterday, there are less than 1,000 of these that have been installed across the entire United States. So we hear a lot about them, and I thought it was necessary for us to mention them, but they're not really an option for 99% of PV customers. But let's go on now to the other Tesla system that Brian just mentioned, which is the Tesla Powerwall. What do you want to tell us about that, Brian?
It is a pretty neat system. It's pretty versatile. It's kind of a, I wouldn't call it plug and play, but it's very user friendly. It's just it's slick, you know. It's aesthetically pleasing, and it's stackable, so you can stack up to 10 of those big battery units. The Powerwall that it's showing, but what it's showing there is the Powerwall is actually the lithium battery pack. It has its charge controller kind of inside of it, so they will sell for about $10,000, like kind of the total system. It has a really user-friendly app that you hook up to your phone. And it's kind of like, how do I kind of, for a user-friendly way of explaining, it's good reserve power for, if you're using it for a reserve, it's good reserve power for like your fridge for a couple hours, you know, like all the computer, audio, visual stuff you'd need, all of your LED lights. If you only have one unit, you might want to be careful about running any kind of electric heat or air conditioning off of it. You'd need a little bit more for that, for, you know, longer durations. But it's a fantastic backup system. So it's also being used in places like in California, where certain times a day cost more in terms of electrical usage. So people will actually store solar energy in the battery, and then they will actually discharge the battery into the grid during the higher cost hours. So it's like an arbitrage, and that's happening. That's a really cool use of this battery as well. So backup, rate arbitrage, and we probably won't get into peak shaving, but it does that too. So we also, if you drive by, I guess this is not really a Fairfield thing, but we just installed the Midwest's first like industrial Tesla power pack as well. It comes in on like a crane and it hooks up to a big factory, and that was kind of awesome.
I want to mention one more thing, which is the topic of what's called dirty electricity. And this is a very technical term. There are two categories of potential health hazards that are experienced by some people when you are in close proximity to electric wiring. Electric wires generate and electric appliances, electromagnetic radiation. And our brains, the cells in our body, communicate in part through electrical impulses. And it is therefore a possibility that the electromagnetic radiation that is given off by wires and appliances can confuse the cells in our body. And there is plenty of evidence that this happens. It is not a fringe opinion. It is a very established thing. There are certain protocols that we strongly recommend and generally almost always use in Maharishi Vastu houses that greatly reduce the possibility of exposure to high, long period electromagnetic radiation. And when photovoltaic electric panels are being installed on a house, the installers also have to be up on this subject so that they can take certain protocols to minimize them. And for instance, if panels are installed on a roof and the roof has a low pitch and the upper story does not have a high ceiling, it may mean that the panels are quite close to the head of a person in the upper story of a house. And the radiation from them can perhaps be within distance of the occupants. Now, DC is less of a hazard than AC, and the radiation drops off with the inverse square of the distance, which means that in most cases, once you're in about a meter, 3 or 4 feet away, there's very little exposure that can be measured. But this is a caution that needs to be looked at when systems are being designed. The second thing is that there's a particular subset of electromagnetic radiation which has a kind of catchy name. That name is dirty electricity, or for short DE, which is how I'll refer to it now, which is a form of electromagnetic radiation which occurs when, in the United States at least, the alternating current electricity happens, the current alternates 60 times per second. We call it 60 cycle electricity, or 50. And certain kinds of electrical events can impose higher frequency signals on top of the base signal of 50 or 60 cycles per second. And these are called high voltage spikes. And those are what is the cause of what's referred to as dirty electricity. We don't have to really understand them technically, but simply to say that while a potential health hazard specifically from DE is not universally accepted, there are plenty of epidemiologists and specialists in the field who believe that they have documented health hazards caused by DE. And therefore, because when we build Vastu, we are building for the full health in every way, mind, body, and spirit of occupants, we want also to consult with authorities, with experts, to see whether there is a DE hazard from anything that we do and what can be done to mitigate it. And in the case of PV, there is a particular potential hazard, which is that a PV system supplies all of the electricity that runs through the house. And so every electrical wire in a house that's getting power is getting any DE that may be generated by, in particular, the inverter, which is converting the DC power to AC. I'm going on at length here. But what I want to say is that the safest thing to do is to install a filter to trap the DE so that it does not pass into the house. And there are a small number of companies in the US, and probably the best one is actually coincidentally here in Fairfield, Iowa, that can block the EMF, block the DE from passing into the wires of the house. And we always recommend, since we are not ourselves authorities on matters of electrical design, that you consult specialists in the field. But this is a potential hazard that we think is important enough to flag. In my own house, I do have filters installed so that the DE generated by my inverter does not pass into my house.
John, someone is asking if dirty electricity is usually created by the utility company and the instability of the supply of the electricity on the grid. Is that something that also is another source of dirty electricity?
It is correct. There are many potential sources of dirty electricity, but specifically to answer your question, it is to varying degrees that the electric grid may, in fact, impart DE into your home. I think you would need someone to take readings to see whether there is any being imparted into your own home and what the intensity of it is. I know that there have been some very famous situations where there was a lot of DE and it had real ramifications. I certainly do not know that as a general rule, there is a significant amount imparted by a utility. I have the idea that there's not, but I'm not an authority.
And how about the life of batteries? How long do we expect these kinds of batteries to last?
There are different battery technologies, each of which have their own lifespans. It used to be a rule of thumb that with a lead acid battery, you should count on 5 years of life, and then you'd have to replace them. In the case of my own house, that's about $6,000 worth of batteries. However, there are batteries, lead acid batteries, that are on the market that have 15-year warranties that commonly last for 20 years and longer. And that's what I have in my house. And I actually got a recycled set of batteries that had never been really used by, they were just there for backup by industry, and I was able to procure them secondhand. And so I have easily a 15-year battery for less than the cost of a new 5 to 7 year battery. So that's the way I would recommend going.
And then they're asking about the disposal of a battery after its life is over without having a negative effect on the environment. How are those handled?
That's a very important point, and fortunately it is covered by federal regulation. Lead acid batteries obviously have a lot of lead in them, and I think everybody on the call knows that exposure to lead can be highly hazardous. It is consumed internally. There's no hazard from having a battery in your house, but if lead is consumed, babies can have brain development greatly impaired. So in the United States, the federal government regulates the recycling of all lead acid batteries. And so when these batteries go out of service, they are collected by recyclers who go through a federally controlled process of extracting the lead so that it can be reused.
This question came in from someone who's in Nepal. So the US rules wouldn't apply necessarily there.
Well, then I would have to say that if you are in Nepal and there is no requirement for battery recycling in Nepal, then when your batteries expire, take them somewhere where they can be recycled. Do not put them in a landfill.
Great. Are there any restrictions to installing PV panels in the Brahmastan of a Vastu house?
Yes. Yes, there would be restrictions on that. The term Brahmastan refers, it's a Sanskrit term. It means the point at the center of a structure of nature at which wholeness, the connection to Brahm, to wholeness is established. And that's a point in a house which has, we create an analog to nature's own Brahmastan. It wants to be silent. And so something which is generating or storing electricity would not go in a brownstone. When someone is building a Maharishi Vastu house and they are installing PV with batteries, we will give them specific guidance on the ideal locations from the perspective of natural law to install their batteries.
Great. And how reliable has your own off-grid system been in all different kinds of weather and storming?
Well, it turned out that there was, we discovered that one component was incorrectly specified, and so we had to replace it, but it had not failed. I don't think we've ever lost power. We have a generator to provide backup if needed when power goes down, but we basically have never run our generator. So I would say that our power supply through our off-grid PV system is probably more reliable than being on the grid.
Right, because every year we go down a few times on the grid.
I'm so sorry to hear that. You have my sympathy.
In an off-grid system where there's battery backup, how many hours approximately will that last?
It depends on how you size your system. In the case of, we describe that consideration by using the term days of autonomy, which is to say, how many days do you want to design your system so that it will operate autonomously, that is to say, without any sunlight falling on the panels. And it is very common to design a system to size the batteries so that they can store enough power that for your typical usage, you might have 3 or 4 days of autonomy. In the case of my own house, we have about a week worth of autonomy because we're actually using a little less electricity than we modeled that we would when we did our design.
That's great. That's much more than I would have expected.
Yeah.
And someone said that from the research they've done, PV panels are known to last more than 40 years.
Right.
However, their efficiency declines over time.
That's right. I've heard something like maybe after 20 years, they're at 80% efficiency, something like that. One possibility, and I'm speaking not as a technician, I wish Brian was on, that if that comes to pass 20 years from now, you may be able to add 1 or 2 additional panels to your display so that you are generating as much power as you were originally. And at that point, adding a new panel will probably cost almost nothing.
Great, wonderful. All right, our hour is coming to a close.
There was actually 2 other questions here, Celia.
Yes, I'm not sure I understand this one question. Is blocking the dirty energy the same as using a Faraday cage to reduce EMFs or EMRs?
No, the answer is those are 2 different things. Faraday cages would block standard electromagnetic radiation or electrical radiation, but DE actually is transmitted through the electric wires themselves into the house. And so a Faraday cage around the emitter does not trap them. There has to be a filter placed just downstream from the actual generator of DE.
All right, that was really wonderful, very full of valuable and technical information. Thank you very much for your interest in Maharishi Vastu architecture, which enlivens happiness and clear thinking. Goodbye for now.